Hey guys, welcome back to my channel. Get creative, keep learning, keep growing. Our today's topic is related to advanced computer network, that is unicast, broadcast and multicast in computer networks. So let's begin. So let us first move on towards two related terms, that is intra-domain and inter-domain routing. So let us see the comparison between intra-domain and inter-domain routing. So intra-domain is any protocol in which routing algorithm works only within domain. On the other hand, inter-domain is any protocol in which routing algorithm works within and between domains. So let us see the difference. So in intra-domain routing algorithm works only within the domain. And in inter-domain routing algorithm works within and between the domains. In intra-domain routing, it needs to know only about other routers within their domain. But in inter-domain, it need to know only about other routers within and between their domain. Okay, so it's all about the same domain in intra-domain, and it's about between various domains in inter-domain. So protocols used in intra-domain routing are known as interior gateway protocols, whereas in inter-domain routing they are known as exterior gateway protocols. So in intra-domain routing takes place within an autonomous network, whereas in inter-domain routing it takes place between the autonomous networks, means more than one autonomous networks. So in intra-domain routing, protocol ignores the internet outside the Earth's autonomous system. Okay. Whereas in inter-domain routing, protocol assumes that the internet contains the collection of interconnected autonomous network. Since intra-domain is within the same network or same domain, so it is least bother about the outside internet. But the opposite is true for the inter-domain. So in intra-domain, some popular protocols are RIP, that is Routing Information Protocol, and OSPF, that is Open Shortest Path First. Okay. And in inter-domain, popular protocols of these are BGP, that is Border Gateway Protocol, used to connect two or more autonomous system. So I hope the difference or the comparison between intra-domain and inter-domain is clear now. Now we will see various protocols. So first one is a distance vector routing, DVR protocol. So it is a method used by the routers to find the best path for data to travel across the network. So each router keeps a table that shows the shortest distance to every other router. So based on the number of hops or steps needed to reach them. So routers share this information with their neighbors, allowing them to update their table and find the most efficient route. So this protocol helps ensure that data moves quickly and smoothly through the network. Now what is a distance vector routing algorithm? The protocol requires that a router inform its neighbors of topology changes periodically, historically known as the old ARPANET routing algorithm or known as the Bellman-Ford algorithm. So the old ARPANET algorithm and the Bellman-Ford algorithm are nothing but the distance vector routing algorithm. So what is a Bellman-Ford basics? Each router maintains a distance vector table containing the distance between itself and all possible destination nodes. Distances based on a chosen metric are computed using information from the neighbor's distance vector. So if there are n number of nodes and n number of routers in a network, then each router maintains a distance vector table containing the distance between itself and all possible destination nodes. So what are the information kept by the DV router? The information kept by the DV router is each router has an ID, then associated with each link connected to a router, there is a link cost, static or dynamic. There is a link cost, means the cost required to travel that particular path, or cost required to travel the data from one node to the another node, or one router to the another router, and then the intermediate hops. Now distance vector table initialization. So distance to itself is 0 and distance to all other routers is equal to infinity number. So these are the initialization part. Okay. Now let us move on to what is unicast. So the term cast here signifies some data, that is stream of packet is being transmitted to the recipient from the client side over the communication channel that helps them to communicate. Now let's see some of the cast concepts that are prevailing in the computer networks field. This type of information transfer is useful when there is a participation of single sender and the single receiver. So you can see here there is a network A and there are n number of nodes in a network A. Then there is a network B and then there are n number of nodes in the network B. So here you have this node which wants to transmit the data to this node. So one node from network A wants to transmit the data to another node from network B. So in short, you can term it as one-to-one transmission. For example, if a device having an IP address of 10.1.1.10.2.0 in a network wants to send the mass traffic stream data packet to the device with IP address 20.12.4.2 in the another network, then the unicast comes into the picture. So let's say this IP address is 10.1.2.0 and the IP address of this is 20.12.4.2. So this is the most common form of data transfer over network, that is unicast. Now let us see how the distance vector algorithm work. So a router transmit its distance vector to each of its neighbor in a routing packet. Okay, so each router receives and saves the most recently received distance vector from each of its neighbor. Means what? The routing table keeps on changing periodically. So a router recalculates its distance vector when it receives a distance vector from a neighbor containing different information than before, and it discovers that a link to a neighbor has gone down. So the DV calculation is based on minimizing the cost to each destination. So if dx of y is estimate of least cost from x to y, estimate of least cost from x to y is ds of y, means the shortest distance between x and y. Okay, now c of v, x comma v means node x knows cost to each neighbor v. Okay, so if you have n number of neighbors to x, okay, let's say y is there, z is there, p is there, q is there. Okay, so x knows the cost to each one of its neighbor, reaching one of its neighbor. Okay, now dx is equals to dx of y, okay, colon y question mark n, means node x maintains distance vector node x also maintains its neighbor distance vector. For each neighbor v, x maintain dv is equals to dv of y, that is if there is a path from v to y. Okay, so from time to time each node sends its own distance vector estimates to the neighbor. So means what? If the distance vector of y is changed now, so it will send the notification to x. So x will updates its distance vector table. Okay, now x knows how much cost is required to travel from x to y. Let's say it is 20, 10 or 20. Then if x knows that there is a cost 30 required from x to z, then for 40 for x to p, etc. So each of the node maintains a distance vector table like this, which keeps on periodically updating, okay, depending on the various conditions. So when a node X receives a new DV estimate from any neighbor V, it saves V's distance vector and it updates its own DV using BF equation. That is Bellman-Ford equation is dx of y is equals to minimum of C of x comma v plus d of v comma v of y comma dx of y for each node y. Okay, means what? It will calculate the minimum. If there exists a n number of paths between any two nodes, then it will take into consideration the shortest path or minimum value path from x to y. So this is how Bellman-Ford equation works. I hope you have understood now. Now let us see an example. Now there are three routers X, Y and Z as shown in figure. Now each router have their routing table. If you can see, this is X routing table, this is Y's routing table and this is Z's routing table. So every routing table will contain distance to the destination node. Okay. Now consider router X. Now X will share its routing table to neighbors and neighbor will share its routing table to the X. Okay. And distance from X to destination will be calculated using the Bellman-Ford algorithm. Okay. So if you can see, the routing tables of the neighbor Y and Z are shared with X. Okay. And X has its own routing table algorithm. Now as we can see that a distance will be less going from X to Z when Y is intermediate node. Okay. So if Y is intermediate node, then you have 1 plus 2, that is 3 is the distance. If we want to go from X to Z, okay, if we are directly going, then the cost incurred is 5 or the value is 5 or the distance is 5, you can say. But if you go by this route, means first you go to the Y and then you go to the Z, then the cost incurred will be 1 plus 2, that is 3, which is less than 5. Of course, you will prefer this route and not this one. Okay. So it will update in routing table X. So in X routing table, it will update it here. So it has cut the 5 and it has updated with 3. So this is how it works. Now finally the routing table for all has been changed by the changes made according to finding the shortest path. So the routing table has made the changes and shared with the neighbor routing algorithm. Means what? It is considering the minimum path for reaching from one node to the another node or one router to the another router using PF algorithm. And periodically the routing table are changed. So this was all about distance vector routing algorithm. So what are the applications of distance vector routing algorithm? Of course, it's in computer networking. It helps route data packets in network. Then in telephone system, it used in some telephonic switching system. Then in military application, it has been used for route missiles. Now, what are the advantages of distance vector routing algorithm? First one is the shortest path. Distance vector finds the shortest path for data to travel in the network. Then the usage, it is used in local, metropolitan and wide area network. Easy implementation is there. The method is simple to set up and doesn't require many resources. Now as you know, anything comes with advantages also comes with disadvantages. So what are the disadvantages of distance vector routing algorithm? It is slower to converge the link state. It is at risk from the count to infinity problem. It creates more traffic than link state since the hop count change must be propagated to all routers and proceeds on each router. Why? Because we need to keep on changing the routing table. Hop count update takes place on a periodic basis, and if there are no change in the network topology, so bandwidth wasting broadcast still occurs. Means even if there are no changes in the routing table, periodically the update is run, which is unnecessary going to use the bandwidth, making the process slow. So for larger network, distance vector routing results in larger routing tables than link state, since each router must know about all the routers. This can also lead to congestion on WAN links. So this was all about unicast routing. Now let us move on to the broadcast. So we will see what is broadcast network in our next video lecture. Till then, bye bye, take care, good night.